And this is me playing the drums. What do you think? Today's lesson is patterns and tables. We're going to use tables to represent and describe patterns. The Indiana Academic Standard is 7.3.9. Example number 1, representing a pattern. Use the table below to find the number of horseshoes for 15 horses. Well, one horse would have 4 shoes. 3 horses would have 12 shoes. 5 horses would have 20 shoes. 9 horses would have 36 shoes. To find the number of horseshoes for 15 horses, multiply 15 by 4. The number of horseshoes for 15 horses is 60. Pause the video if you need more time to copy down the notes. For example number 2, finding the value of a term. Which sequence follows the rule -4z plus 12, where z represents the position of a term in a sequence? Well, we're going to write our positions over here to the left. So we have position 0, then 1, 2, 3, and 4. When the position is 0, we have -4 times 0 plus 12. -4 times 0 is 0 plus 12 gives us a value of 12. When the position is 1, we have -4 times 1 plus 12. -4 times 1 is -4 plus 12 would give us 8. For position 2, we have -4 times 2 plus 12. -4 times 2 is -8. -8 plus 12 is 4. For the position of 3, we have -4 times 3 plus 12. -4 times 3 is -12. -12 plus 12 is 0. And for the final position, -4 times 4 plus 12. -4 times 4 is -16. -16 plus 12 is -4. So the correct answer choice would have to match the value of the terms as 12, 8, 4, 0, and -4. So the correct answer choice is C. Pause the video if you need more time to copy down the notes. Example 3. Using a table with a sequence. Write an expression to describe the sequence 2, 4, 6, 8, 10. Then find the 10th term in the sequence. Position 1 is 2. Position 2 is 4. Position 3 is 6. Position 4 is 8. Position 5 is 10, and so on. Make a table that pairs the position of each term with its value. So for position 1, the value of the term was 2. We took 1 times 2 to get 2. For position 2, we take 2 times 2 and get 4. For position 3, we take 3 times 2 and get 6. For position 4, 4 times 2 is 8. For position 5, 5 times 2 is 10. So for any position, we're going to multiply it by 2. So for the nth position, we would multiply it by 2, so it would be 2n. The relationship is multiply the position of the term times 2. Let n equal the term number. You can write the expression n times 2 or 2n. So n times 2 would equal 10 times 2. So the 10th position would have a value of 20. Pause the video if you need more time to copy down this example. Don't forget to write down any questions you might have that we can discuss in class tomorrow. Quick check number 1. The table shows the number of miles a car can travel using different amounts of gasoline. Complete the table. Find the distance the car can travel using 15 gallons of gasoline. For 1 gallon, you can drive 18.1 miles. For 2 gallons, 36.2. For 3 gallons, 54.3. So we're taking the number of gallons times 18.1. So for 4 gallons, you can drive 72.4 miles. For 5 gallons of gas, you can drive 90.5 miles. So for 15 gallons of gas, it'll be 271.5 miles. You can drive 271.5 miles on 15 gallons of gas. Pause the video if you need more time to copy down this example. Don't forget to write down any questions you might have that we can discuss in class tomorrow. Use the rule 2n plus 3, where n represents the position of a term in a sequence. Find the first 4 terms in the sequence. We can create a table to organize our information. Set your table up so you have the term, the rule, and the value. The terms will be 1, 2, 3, and 4. Now let's substitute in the first term. So we have 2 times 1 plus 3. That has a value of 5. For term 2, 2 times 2 plus 3 would have a value of 7. For term 3, 2 times 3 plus 3 would have a value of 9. And for term 4, 2 times 4 plus 3 would have a value of 11. The first 4 terms would be 5, 7, 9, and 11. Pause the video if you need more time to copy down this example. Don't forget to write down any questions you might have that we can discuss in class tomorrow. Write an expression to describe the sequence: -8, -7, -6, -5. Find the 10th term in the sequence. Creating a table could be very helpful in figuring out this sequence. In this particular example, for the first term, we have to try to figure out what are we doing to 1 to get -8? What do we do to 2 to get -7? What do we do to 3 to get -6? And what do we do to 4 to get -5? In all of these cases, we would be subtracting 9. We're taking the term and subtracting 9. So our rule would be, our expression would be n minus 9. So to find the 10th term, we're going to take 10 minus 9, which is 1. So the 10th term in this sequence is 1, and the expression is n minus 9. Pause the video if you need more time to copy down this example. Don't forget to write down any questions you might have that we can discuss in class tomorrow.